ke au I ka huli wela ka honua, o ke au I ka huli lole ka lani, o ke au I kuka I aka kala, ho o malama I ka malama. O ke au o makali'i I ka pō, o ka wale ho o kumu honua. O ke kumu o ka lipo I lipo ai, o ke kumu o ka pō I pō ai. And such are the first lines of the Kumulipo, the Hawaiian chant of creation. You know, as soon as the Kumulipo creates a setting in which life exists, life is said to spring out of the slime. It's really amazing, you know, since the ideas of the origins of life on Earth also have this primordial soup in some reckonings. But in this case, the recognition that water and that complex creation of life out of water and slime is what the origins of life are for in Hawaiian thought. And life doesn't spring straight out of slime into complex creatures like human beings, but begins with the simplest polyps. One of the first complex creatures that's mentioned in the Kumulipo is a coral polyp, which even in modern systematic thought is one of the simplest forms of animal life.
The Hawaiians really knew the importance of corals. The Kumulipo, or the creation chant, has Po'ele and Kumulipo, the two first humans. The first thing that was born was the coral polyp, and then the coral colony. This showed that the Hawaiians really knew that the coral was the basis for all life in the ocean. From the coral came forth all of the limus or seaweeds, all of the different fishes, and you can see that. All of us who have gone snorkeling in a sand area, you don't see too many fishes or other things, but if you snorkel over an area that has a lot of live coral reef, you're going to see a variety, a diversity of different organisms. Inside these corals, there's a little single-celled limu, a little algae, and it has a symbiotic relationship with the coral. And when the temperatures get 1 or 2 degrees Celsius higher than the ambient summer temperatures, then that zooxanthellae will leave the corals, and the corals turn white. Now the color of the corals, you see these brown and bright greens, these have to do with the zooxanthellae. When the zooxanthellae leave the coral, then the corals turn white. If the temperatures don't return to normal within a few weeks, the corals will die. There have been some major bleaching events throughout the world. At the Coral Reef Ecology Lab, we're interested in the coral reefs. And the coral reefs involve a wide variety of things. And leading scientists now know that there are major impacts that are going to be affecting coral reefs in the future. And these are not only global impacts, but also local impacts as well. So we're trying to address these problems. And two of the main problems with coral reefs globally have to do with global climate change. One has to do with anthropogenic or human-induced atmospheric gases, mainly due to fossil fuel burning that is going into the atmosphere, and it is raising the atmospheric temperatures. It's also raising the ocean temperatures. So global warming is affecting our coral reefs as well as many other things. So we're looking at how corals grow under different temperatures, what species of corals will tolerate which temperatures best. Some of the things that can be done, you know, we're busy trying to provide managers with information so that they can make sound decisions. But people as individuals can also do things by recycling, by using less resources. And if everyone pitches in, it will make a big difference in the amount of carbon dioxide and other gases that are being released, because a lot of that is due to our automobiles as well as other types of fossil fuel burning. Also, corals have a microsporine-like amino acid, or an MAA. It acts like a sunscreen. It protects them from UV light. So now they're putting this in plastics and paints so that that can protect the houses and other things that they use from the sun. The corals are also used in medicine for calcium as well as bone replacements, because these are very porous, and the bones and the blood vessel of humans can grow in them, and there's no antigens, so the body's not going to reject them. So often it's easily shaped as well. So often bone replacements are actually using coral skeletons. There's a wide variety of uses, and corals, like I said, being the basis of the whole ecosystem, it's really important for us to conserve them.
Growing up here definitely gave me a unique appreciation of the fish here, and like I said, I'm an avid fisherman and diver and surfer, and even in my short lifetime I've seen the animals here disappearing at a kind of disturbing rate, and that has driven me to this field, to aquaculture. First of all, being able to produce fish to eat and to have, and second of all, most importantly, not taking from the ocean, being able to sustain yourself. Native Hawaiians, you know, we got one over here at Heia, major fish pond. The Hawaiians realized early on that you need to take from the environment in a sustainable manner.
What the Hawaiians did was they create these ponds on the reef or inland in bays and accumulate fresh water in these ponds. They can regulate it with these gates that they call makaha. And they regulate it with certain fish, sweet fish that eat little limu, like brackish water. Brackish water is mixed with salt and fresh water. And we're not sure yet, this is other kind of research going on, but maybe they just like the temperature difference, just the freshness and salinity, some research I have one student working on. But the nutrients, and it's something not that well understood. The Hawaiians seem to have really had it down packed. They knew exactly kind of the sweet spot of how much fresh water to put into the pond. So they had all their fish right there, and they don't have to go way out to the ocean. You don't have to go, you know, they never have Food Land and Safeway, so you go to your fish pond. And we're working on how much water comes out affects how fresh the water gets in the ocean and how much nutrients come in. So what you do way up Mauka, if you take all the water off of the land, or if you change how much water goes in, what you do way up Mauka affects even the fish in the ocean and in the reef. Your limu, a lot of places, all the old people say a lot of limu is gone now. We're not sure why. Some of it is people pick too much or don't know how to pick right. But again, we're not for sure, but we think water is changing. So the more I study, the more I'm amazed. I mean, it seems like I'm trying to play catch up to get a glimpse of how they understood the system. So to me, if you don't truly understand that place, you cannot do a good job of using a numerical Western water model effectively if you don't truly understand how things work in that place. It's an example of, so to me that's an example of someone cannot just blindly come in with something taught on the East Coast and model a Hawaiian system if they don't start to understand the little nuances, how the system works, the exceptions to the rules that aren't in a textbook. And that's where Hawaiian knowledge becomes very valuable. The kupuna from the area know all the little exceptions to the rule where that exists. So that's a challenge in my life, is trying to find a balance of both, and something I'm still struggling with.